Hello. Many of you have asked what to do when you have an expression or part of an equation that looks like this. It's got a minus and an open parentheses and then some algebraic expression in here and a closed parentheses. Perhaps there's a number in front, A, B, something, right? What do you do with this? What does it mean? And I almost look at it like its own symbol. Like there's a minus, open parentheses. What is this thing? So I'm going to give you, hopefully, a little insight into what to do with this. Alright, so let's start. Let's just do some recall. Let's remember some things before we get going too far. Let's say we have a number. Let's say we have a number 5. Right? 5 sits on a number line. So I get a line, 0, and 5 is be over here, right? Because the positive numbers are to the right of 0. 1, 2, 3, 4, 5. And if I said, well, what's the opposite of 5? You'd say, well, it's in the other direction. Here's 0, and we'd go in the other way. 1, 2, 3, 4, 5, and we'd call it minus 5. Or we'd say this minus is the opposite of 5. So we have the number 5 sitting right here, and we have its opposite, minus 5. Alright? 1 is in one direction, 1 is in the other. Now notice that we can get the minus 5 by multiplying by negative 1. If I take a negative 1, that quantity, and I multiply it by 5, what do I get? Well, 1 times 5 is 5, but I know that if I have a negative times a positive, then my answer is going to be negative, so I get negative 5. So notice that by multiplying by minus 1, we get the opposite. Alright, so I could take minus 1 times 5. So I'm going to multiply that by minus 1, and I get minus 5, or the opposite of the number 5. If I took minus 1 and multiplied it by negative 5, well, we know that a negative times a negative gives us a positive, because there's a multiplication here. This is also a multiplication. We get a positive 5. So each time my answer is the opposite of this number. 5 is the opposite of negative 5. Negative 5 is the opposite of 5. Okay, how about a more complex expression? So how about something that looks like x minus 2? Nice expression in mathematics. What's its opposite? I guess I don't need that there. What's its opposite? Well, the same as 5 had an opposite of negative 5. X minus 2, this whole thing has an opposite. I'm going to put it in parentheses because there are two terms. Has an opposite that looks like that, right? We can also obtain this by multiplying by negative 1. So I'll take the original expression, x minus 2, and multiply by minus 1. Alright, so let's do that. I'm going to do that on the next page. So I'm going to take this minus 1, our yellow minus 1, and I'm going to multiply it by the expression x minus 2. But as we found with the number 5, if I multiply an expression by -1, I just get its opposite. So over here I'm going to get the opposite of x minus 2. And we write that as negative x minus 2. Great. That's cool. Okay. Let's take this one step at a time now. And let's look at this -1 times x minus 2. So I have -1 times x minus 2. That's -1 times x plus a -2. We've done this before where we change a subtraction into an addition of a signed number. Remember that? Remember, I'll write it down here. Remember, let me write it over here. X minus 2 is the same thing as x plus a -2. Good. Now I can look at this particular multiplication that's sitting right here and say, now I can use the distributive law. -1 times x. So I have -1 times x. And then I'm going to add, if you remember the distributive law, you can look that up in your book also. I'm going to add to that -1 times a -2. All right, let's work that out. -1 times x, well, we know -1 times any number gives the opposite, so I get the opposite of x, or negative x. And then I'm going to add -1 times a -2. A minus times a minus is plus, so I'm going to get -x plus 2. Well, wait a minute. Let's look at our original expression. Our original problem, or our original expression was x minus 2. Right? That's what we started with. And we multiplied it by -1 and got the opposite. And it looked like this. Right? This was our original problem, what to do with this minus in front. What we ended up with was this. Minus x plus 2. Right? Same thing. So let's write that out and see what we get. We get negative x minus 2 that came from here happens to be equal to minus x plus 2. If you look at each term inside this parentheses, the x, when I removed this parentheses by multiplying by -1, this x, which was a positive x, now became, that's right, a negative x. The sign changed. This minus 2, this term, was negative, but over here, notice, it's positive. So you may hear that if you have a minus in front of a parentheses, it simply changes the sign of every term. But as you can see, there's quite a bit behind changing that sign. Let's go back and look at that original problem in this FAQ, frequently asked question. 5 minus parentheses x minus 2. How to simplify this problem. So again, you'll see that we have this minus and then the parentheses, right? There it is. There's that sort of strange symbol. But you and I both know now that that's actually multiplying by -1. So this is the same thing as 5 plus a -1 times x minus 2. And that's 5 plus, I'll use the distributive property with the negative 1, so negative 1 times x, negative 1 times minus 2, so negative 1 times x gives me a minus x, plus minus 1 times minus 2 is a plus 2. Normally we don't put a plus minus in an equation like this, so we'll get to that in a minute. But first of all, I look at this expression and I notice I have two like terms. I have a 5 and a 2, so I'm going to go ahead and add those together and say this is 7 plus a minus x. This is kind of messy, plus minus, right? So let's recall over here on a little piece of scrap paper that if I have 7 minus 2, that's the same thing as 7 plus a minus 2. Oh, so instead of minus 2, we've got x. So we could just say this is 7 minus x. And that's our answer. That's a simplified version. Great. Let me do one more for you. That's similar. It's a similar type of problem. Let's take, say, 8 minus 3 times the quantity 2 minus y. Perhaps this is a little easier for you. I don't have minus 1 now, I have a minus 3. So I'm going to rewrite this as 8 plus a minus 3 times this quantity 2 minus y. Now remember, my 2's look like a z without the line. If let me put it over here, a z, my z would have a line through it, 2, so my z is going to look like z, and my 2 is going to look like a 2. So this is a 2, and I'm going to distribute the negative 3 now. So I'm going to bring down the 8. Remember, we do multiplication well before addition. So I'm going to do this multiplication first. So I have the 8 plus minus 3 times 2, a negative times a positive. Different signs, I get a negative, in this case 6. And then I have minus 3 times minus y. Minus 3 times a minus y is going to be plus minus 3, that would be positive, right? Minus 3 times a minus y gives me a plus 3 times y. Again, we're going to combine these like terms, and I get 2 plus 3y. So sometimes it's easier to look at these expressions if there's a number here. If there's a number, it's quite a bit simpler. But just remember that if I don't have a number, if I have something like 8 minus 2 minus y, something like that, where there's no number here, in reality there is. There's a 1. All right, they're all treated the same way. So there you go.